So two students are racing typical garden snails and they're measuring the distance that their snails travel in 1 minute. Let's say Peyton's snail travels a distance of 2/10 of a foot, whereas Dean's snail travels 4 times as far as Peyton's. How far does Dean's snail travel? So let's look at this problem mathematically. We know that Peyton's was 2/10, and we know that Dean's was 4 times as much, and that word 4 times tells us that it's time to multiply. Now, looking at this, it's a very simple fact problem. I'm going to even interpret it over here. 2 times 4. 2 times 4 is 8. We know that, no problem. That's the easy part. But now let's ask ourselves, how many numbers are behind the decimal point? And it's 2. I always tell you to write that number up there to remind yourself. When I have the number 8, there's really not enough numbers here, but I know my decimal point is here, so I need to make it smaller. Why do I have to make this number smaller? Because both of the numbers I multiplied by are both in the tenths place. So that means my answer needs to be smaller than 8, because that's in the ones place. So if I go 2 spots, I always got to go to the left when I'm going smaller. 1, 2. My decimal point would be here. So then you have to think to yourself, what is going to go in this empty space? And it's going to be a 0. So when I fully write this answer out, I'm going to write it like this: 0, decimal point, 0, 8. So that's 8 hundredths. That's 8 hundredths of a foot. It is so important to look at these like a regular multiplication problem. Look at the basic fact. 30 times 2. 30 times 2 is 60. So I put that down, but then I have to go back and remember how many spots were in the decimal point. It's 3. So like always, I always put that up there, and it's 3 spots. So there is not 3 spots here. The next question you should ask yourself is your answer going to be bigger or smaller? And in this instance, we're multiplying by 2 decimal point numbers. So that means it's going to be smaller, definitely smaller. So we said 3, so my original decimal point is here at the end, if this is the ones place. So now I'm going to move it 3 spots to the left because we're getting smaller. 1, 2, 3. My decimal point would be here, and there would be a 0 in the front. So because there's a space here, I'm going to put the 0 here, meaning that it is 60 thousandths as the answer, or another way to write it would just be 6 hundredths. It's the same thing. When I have a 0 at the end of a decimal, you can get rid of that. We don't need it there. Please try this one on your own. Pause your video and do it. Now, I'm going to work through it, and so I'm thinking about the basic fact. 5 times 7 is 35. And when I look at how many spots are in the decimal, 1, 2, 3. If you need to, even circle them. I like to write it to the side. Get in that habit. It's helpful. So 3. So my decimal point starts here. 1, 2, 3. Get used to doing these loops too. I always remember it from doing it in middle school science, and I still do it to this very day. There's my decimal point. In the front goes the 0, and there's a spot missing, so what goes there? That is my 0. So my answer to this one is 35 thousandths. Let's try one more. Please try this one on your own. Pause your video, and then we'll do it together. My basic fact is 5 times 2. 5 times 2 is 10. I have that in here. How many numbers are behind the decimal? 1, 2, 3. So I write that there. Now I'm going to take my decimal point, which is after my 1 spot here, and I'm going to move it 3 spots. 1, 2, 3. There's my decimal. I have a 0 in front, and it just so happens in this one I have to put an extra 0 behind. So my final answer is 10 thousandths. Another way I could write it is 1/100th, because I can get rid of the 0 behind the 1. It's not necessary to be there. I hope you understand this lesson, and we'll be working on it again tomorrow in class.